All right, everybody good? Set. All right. Anybody verify that sound's working properly and everything for me? Please. It looked like it was. Okay. All right, so it's good. So today is all about object inheritance. We've gone over already a couple times, as we have with gone over. So everybody understands what inheritance is? Yes, inherit from an object. Everybody knows how to. Class, colon, subclass. I'm not going to spend too much time on it. I'm just going to reiterate here. So we have class 1, and we have class 1. And it says that class 2 is this type of object. And if we have something in here like then from in here, we can access the base inherited value, or inherited field in this case. So that's inheritance at a very simple level. We've gone over this more in depth on other classes. So does everybody pretty much understand how this works? Cool. You guys understand, obviously, the access levels. We've gone over that several times. Protected, private, public, internal. Which, by the way, with internal, I was saying previously namespace, because it's usually how I work with assemblies, is usually all in one namespace for what I'm doing. But that's actually incorrect. It's actually by assembly. So if you're creating a library, then regardless of namespace, internal means internal to that particular set of code. If you go to start another project, it's going to have a different assembly. Then even though it may be the same name, access to those fields or properties or classes or methods. All right, cool. Let me just double check what they want me to go over here. Fields and methods, we've already gone over that. Called parent class constructor. Oh yeah, you guys remember that, right? We have base constructor, which we're not assigning anything, but we could do on my int by default equals 25. Oops, that's an int, not a float. 25. And then if we come in here and we create an instance of class 2, then class 2 that accepts second integer. We want to set that in the constructor. Then if we do this, when we instantiate this sending a parameter, this will still be set to 0 because it's not going to call the base constructor. So in order to get around that, and if you want, do you want me to run this to demonstrate that, or does everybody remember this from before? Cool. All right, so if we have class 2, oops, I don't have a single, so I'll do, and let's make this public for the sake of it. Oops. Forgetting what language I'm in here. I'll use the method to demonstrate the inheritance, and then console that. Okay. Now if we run this, we should see 0 and 100. No, it's 25 and 100. Wait, maybe I got that mixed up. Jake, can you remember if it by default calls the default constructor on its parent? I can't remember. Maybe it does actually. So let's try this. Oops, not here. Inheritance. I didn't think it automatically called the base constructor or base default constructor. Maybe it does. Oh, yeah, actually it does. Because it just threw an error when I overrode this and created one that took a parameter. This one doesn't. This one's trying to call the base default constructor. So if I delete this, no argument given that corresponds to the required formal parameter, my int class one default, try and call the base constructor. If we do this, and that'll be set. So here, we'll just actually disregard this one and set this to, well, no, we'll do this, yeah. We're just going to ignore this. It's going to give me a, so now if we run this, because we're not doing anything in the default, which is called by default with this one. So in order to get around that, set this one. So if we say base my other int, in order to call the constructor on this class, we'll see 25 and 100. Does everybody get what that happened there? It's kind of hard because it's such a small screen. I'm going to scroll in the parent class.
In the parent class.
Yeah, a parent constructor.
So it wants to call that blank one that you told it don't call out calls.
Yeah, by default it'll call the default constructor with no parameters. Anybody get that? Cool. Go further into this stuff if you want. Okay. And we went over overriding stuff. I did actually want to go over what we went over last time with the new versus override versus virtual and all that stuff. We'll just get rid of this. We don't care about constructors right now. So to automatically comment and uncomment by default in Visual Studio. C to comment and Control K and then U to uncomment. You can go into preferences and choose a shortcut you want. But yeah, press Control K and then U to uncomment, Control K and then C to comment. It's probably Command, or I don't know, did they leave it as Control on? Well, you guys are using a virtual machine, so it doesn't matter. So if we have then so this one's overriding and saying, no matter what, use this regardless of what, because this is basically this, right? Deriving from object here. It's the toString method within object by default, unless you override it. Then it says, even if this is passed as an object, string method to use regardless. Class 2 is not overriding. It's just saying this is a new toString method. So if I'm cast as a class 2, then use this method. But if I'm cast as any other object, any other base object, parent object type, use whatever they have set. So if I cast this, and I'll demonstrate this in a minute, if we instantiate class 2 but cast it as a class 1, if this were override, it wouldn't matter. It would always use this one because it was instantiated as class 2. Different names in class 1 and class 2, or is that confusing at all? Okay, all right, cool.
I didn't know you can use new as a method signature there.
Yes, it's obviously different than the new keyword for instantiation, but it's kind of doing the same thing in a way. Kind of, not really, but it's the same idea. It's new.
When do you use it? Do you use it when there's another method with the same signature?
Do have the same signatures, and this is a child. It all depends. I'll explain the behavior above. So let's say that we have class 1 equals new class 2, which is totally valid because it can be cast to a class 1 since class 2 is technically a class 1, right? So we can do this, or we could say class 2 and then say class 1 equals class 1, which then effectively casts class 2 instance to class 1. But it's just easier to not class. I want to demonstrate it here first. So right now, if we say class 1 equals new class 2, say class 2 equals new class 2, and then we do a console write line. This is going to be C1. It's going to be C2. This one's a class 1 and this one's a class 2. Now, this is something fairly peculiar is going to happen to. This is what we ran into last time. So they both are using the class 1 method, right? But the reason why is because it's actually casting this as an object when it gets passed into WriteLine, because WriteLine function or method doesn't know what's being passed to it. It's just being passed. It accepts any object. So it's being cast down to its lowest possible object type, which is class 1, or excuse me, is object. But because we overrode the toString function, it's saying regardless of what my base class is, or regardless of what class is, always use this one. This trumps all. So now it's using this version. So if we actually change this to new, we'll have a different output, and it'll just say the type class or the class type, because now it's actually using the object because it was cast down to object, and we don't have any override stating use my method, not the base object type method. So it's using the method for toString. So everybody see that so far? Understand what's going on there? Would it help if I wrote it out any differently or anything, or is anybody confused? Okay, cool. Which, by the way, would one of you mind keeping an eye on chat in Hangouts? I can't really easily check it in here. Thank you. So now, we do override, run this again, we'll see, again, we go back to class 1. It's being cast as an object. It's actually just, effectively, when it gets passed in there, it's basically the same thing as this. Doesn't matter. Equals object. That's basically passed in here. So, and that happens for both of them, obviously. Now, tell it explicitly to use the result from the toString, because this one's not passing the object, this is passing the string from. So nothing's getting cast down other than the fact that it knows that it's a string. So if we do it this way, then you see that it comes from class 1 or class 2, because now we're explicitly stating the toString method of class 1. But if we did this, and again, we'll have, because we're explicitly stating, regardless of what happens, use this one as the method. So even though this is a class 1, we overrode it and forced it to use, because it is a class 2. And that changes, obviously, if this is explicitly a class 1 and not a class 2, because it's not going to use an overridden method from an object it doesn't belong to, from a type it doesn't belong to. This is explicitly a class 1. It is not a class 2, so it's not going to use the overridden method. It can get a little confusing, so honestly, feel free to speak up if any sense. To an object, or to, well, to cast anything, it's like, let's say that you wrote a method that, well, actually, it doesn't matter, but you wrote a method that accepts a class 1, object type class 1, and it does something with that class. And you know the fixed signature, so you know certain fields and properties exist. If I write class 2 and have a button because it needs extra functionality, but I need to use that method that accepts class 1 type, I can just cast it down to class 1 and send it to that method. It doesn't really matter. So because it still has everything that a class 1 has, it just has additional 2 you can't take away from. You can override and change, but you can't delete. That's a class 1, and you have an inherited, or excuse me, a child, just cast it down and use it in the same situations that its base would normally be used.
Everything, you know, when you do the column right there.
Yeah.
You know, what explicitly extra is the casting doing the inheriting is.
Guess maybe I'm not understanding what the question
So like you already inherited.
Mm-hmm.
So you have everything from class 1.
Mm-hmm.
So when you do class equals new class 2, why do you need the class 1 new class 2?
Here. Actually, this may not be the best example because it'll probably automatically do it. Let's see. Okay. That. Yeah, that's going to automatically do it. Trying to think of an instance. I'm blanking right now. I do it all the time, but I can't think of, I'm trying to think of, Jake, can you think of a specific instance where you have to cast? Because like this one will automatically do it, an automatic conversion, but like an interface, it wouldn't do it. You'd have to explicitly cast or no? No, an interface would if you inherit from an interface.
So the only time I ever cast is if I'm explicitly doing it, and if it's, I'm trying from like a dynamic object to
Yeah.
dictionary or something.
Yeah,
like
right.
that.
Yeah.
Otherwise, just that's the messiest thing that I have to deal with. Is
Yeah.
I'm trying to deal with just a straight up object. You don't want to actually have to mess with getting types and
Right.
trying to needle down into that. It's a lot easier just to explicit.
Yeah.
Other than that,
Yeah, I can't think of a really good example right now either. I know I've done it before for other reasons, but
Like we inherit everything, and so we have access to all of us have access to.
yeah. An example. The right line does it actually, or why right line accepts this. For non-right line. But for whatever reason, we want to treat this object. For whatever reason, we can only accept it as an object because somewhere in the program is going to send us objects, but we know that they have to be objects, but we know that they're going to be class 2 or whatever. So then you would an object. And if we do this right now, let's get rid of this one so there's no confusion. Oops. There we go. Comes from class 2. Of course it does. Everything, yeah. That's why. I added that other override in there. So now it'll say it comes from class 1 because it's an object. But let's say that we know that even though it's cast to an object, because sometimes things have to be cast down to an object because of whatever you're storing them in class 2, then in this case, you would just simply say, actually, we can just do it right here. And now when we do it, we'll get the class 2 method. Or you could last time, which was I guess really the big thing is you don't usually, now that I'm thinking about it, you don't usually cast to a base class unless there is a method in the base class. Like in this case, if we wanted the of the base method, we could cast down to that object and use it. Like if we wanted to use this is class 2, but we want it to act like class 1 because we have a new method here, but we want to use their version of the method. You could do it that way. That would be the only reason I can think of that down.
So if you're going to say, take class 2, I know you've got some stuff, class 1. Use.
Exactly.
In another case, I won't cast you, I want to use your other stuff.
Right. Yeah. Asks. I mean, no, I shouldn't say usually. There are reasons for both, I'm sure, but I have examples right now, other than you want it to behave like that class. But most of the time, it's casting from a lower to one of its inherited members, or one of its inherited, or one of its ancestor types. Yeah, exactly. Yeah, because like instances where you go down, because it'll usually do an automatic conversion if it can follow the trail of inheritance, then it'll just do the conversion for you. If it doesn't know where it came from, then it won't be able to do that. But in this case, we're explicitly saying it's a class 2. The compiler knows it is a class 1, so anything that accepts a class 1 will take a class 2. Did that help at all, Ike? You want me to say it all again? Are you listening? All right. Cool. So, yeah, so we went over, we had your own that you knew, or not even knew, but just in case somebody wanted to override your own. So if we had like, let's say, protected at my string. Make it public. So now if we're down here, this one just exists as a member of class 1. And this works just as, is it going to give me a warning? Yeah. It hides an inherited member. So it tells you that the other one exists. So if you write new, it gives you that warning so that you know that you're that is in your base. If you write new, then it works just like the other one did.
So it run 5, it just would do stuff you might not want to do.
Well,
Green squiggly.
No, I mean it'll run fine. It's just telling you the way your parent class that your base class that you're inheriting from has this already. Did you know that you're overriding this? But obviously, if you type new, then it was intentional. You know what you're doing. Should know what you're doing. But if you do this to make sure that this is always the new version, it'll give you an error. You can't override it because it's not a virtual method. So you can create a new to create your own version of that method for that particular class. But you can't override it unless you explicitly state this as virtual. Once you state this as virtual, then you're saying, okay, I give anybody who inherits this class permission to override this method. So if you don't mark it as virtual, then nobody who inherits your base, or you as a base, can strictly override that. You can only create a new version. But now with this overridden, then it doesn't matter whether we're class 1 or class 2, if we are instantiated as class 2, obviously. But it doesn't matter what we're class 2, it's always going to use this version of that, which follows the same rules as this one. So toString is marked as virtual within the object class. Do you need me to demonstrate that? Or, I mean, it follows the same rules as before, but I can demonstrate it if you'd like. Everybody clear? Cool.
Would there be an error if class 1 didn't have virtual
Yes.
and didn't have override on class 2?
No, so if you didn't have override on class 2, it'll give you a warning saying that you're hiding an inherited method, or a method from an inherited member. It says class 2.getMyOtherString hides inherited member class 1.getMyOtherString. Use the new keyword if hiding was intended. And it's not going to stop you from running it, but it's going to tell you that you're doing this so you know that you're potentially causing a problem. But if you use override and it's not marked as virtual, it'll tell you that. It'll tell you that class 2, myOtherString cannot override inherited member because it's not marked virtual, abstract, or override. So, and yeah, I should specify that too. If it's marked override, then you can also override it again, as we demonstrated before. And we'll get into abstract in a bit, but. Mark as virtual, error goes away, it's all good. Was somebody else going to ask a question? Did that answer your question? Okay. Somebody else going to ask a question? I thought I heard somebody get ready to speak up. Okay. Okay. Oh, actually, no, it's abstract. Thought there was something else in the middle. All right, so abstract. Abstract is kind of a fancy word for saying incomplete. Not quite what it means, but basically not abstract. Abstract. We've marked this as abstract. You'll see up here now we have an error. And I create an instance of an abstract class. So since it's marked abstract, we're basically saying that this is not a valid object to actually instantiate. You can't create instances of this class. The only thing you can do is inherit from this class. So we just create a basic scaffolding for somebody to use in a particular class, mark it as abstract, and say this isn't a complete picture. If you want to actually use this class, you need to implement some additional features. So then we could add, make this abstract. And you don't define a body. Abstract, again, is just scaffolding. There's no inherent, what do you call it, functionality to this. You're just marking that this is going to have to exist in whatever inherited class. So if we delete this, actually, let's just not delete that. I'll comment it out so it doesn't exist. We'll get an error on class 2 saying class 2 does not implement inherited abstract member, get my other string. So what we've effectively done here, and see, I'll delete that because that's not valid. And this also allows us to do this. So that's class 1. We can still use it as far as casting and everything else like we can anything else, but you can't instantiate it. So we create class 2. It's telling us that this is an unfinished class, essentially. Here's the framework. Implement the rest on your own implementation. So we come down here, we have an error until we uncomment that. Now we've implemented a required method that's specified up here. So it's basically creating a framework and forcing someone to write their own implementation of whatever you want them to. Whatever you mark as abstract has to be implemented. So now this functions exactly like it did before, except we can't instantiate a class 2, or excuse me, a class 1.
It's right there. If you run that abstract and those methods have to be implemented, when it gives that red squiggly under class 2, will it tell you the name of all the methods you have to?
Oh yeah, yeah. So if we have, I'm not going to change that. I'll just make this 2 and 3. We'll list them out and say you haven't implemented, get my string, my other string 2 and my other string 3. And then actually, with this, yeah. Actually, that's what I wanted to see real quick. So Visual Studio will help you fix all or finish all that. Like if you don't know what the signature of those functions are or those methods, what they return or anything like that, Visual Studio already does that, thankfully. So let's get rid of these. So everything's good. So there we go. Everybody understand that? I mean, really, it's an incomplete class that has scaffolding that forces the person who's inheriting it to implement specific members. That's it. Can be very helpful if you have a really dynamic framework that you want people to use that just basically provides all of the base functionality and then a couple helpers here and there, but ultimately is meant to be used however you set it to, but you need specific methods to be implemented for it to work properly. So. Does everybody get that? You want me to go into it any further? Yeah, we've already done the, I can go over that again. We already know the inheritance as far as fields and properties, right? You guys need me to go over that again? Okay. And then, yeah. Did everybody do the prep work? So you saw the class diagram and how you basically just draw out inheritance. It's not terribly complex, but it can be confusing. So if you need me to. Other than that, really, honestly, that's it. We've hit on a lot of these things here and there. There are just a few key things that we hadn't really touched on, like abstract, virtual, and things like that. So yeah, I'm done unless you guys have any questions.
On those class diagrams, the keys that they show, are those like best practice universals? Like most people are going to use those same keys.
Refresh my memory.
Like, there's just like the arrow with the diamond.
Oh, yes.
Like
I mean,
that stuff, is that usually universal or is it just whatever?
I honestly couldn't say. I mean, I just write it out differently than that. So, but I mean, I haven't worked in any like huge corporate environment where maybe they use it. Do you ever use class diagrams to describe objects? Yeah, I don't either. So, I mean, it's good for your own personal use, especially if you're writing stuff so you can get your head around what's going on. I have my own way of writing them out. I usually don't use I just circle and then have a line or something. I mean, yeah, well, it depends on the object. Some of them I just don't. Yeah, that's another way is just start writing and see where it fails.
Don't do that.
That's a bad idea, actually. Yeah, I don't really know that there's any particular standard. Maybe there is. I've never followed it. Anybody else? Did you have a question?
Yeah, I would go over the difference between abstract class and interface. I think one of them you don't have to implement anything, but I don't know.
Yes, so interfaces are a little bit different. We'll go over it in like 2 more classes. So you can go over it now, but if you people probably want to work on stuff, I mean, we can go over it if you guys want to. If you guys want to go over interfaces at all. All right, let's go over it in 2 classes. Cool. All right, thanks, guys.